Welcome to the deep dive. Today, we're plunging into, well, what might seem like a pretty technical area, but honestly, it's fundamental to our digital world. Enterprise data storage and management. We're kind of going under the hood, looking past the flashy apps.
Right, looking at the engine room.
Exactly. And our guide today is a bit unusual. It's a set of practice questions and the explanations that go with them for an exam called D-ISM-FN-01.
Information Storage and Management Foundations.
Precisely. Now, we're not here to, prep for the test itself,
You know,
but these questions, they're designed to hit on the really practical, the real world stuff, the challenges, and frankly, some pretty clever solutions for keeping data safe, fast, accessible. So our mission is kind of look beyond just the right answer. We want to find those aha moments.
those insights hidden in the explanations.
Yeah. Just for context, the exam itself is about 90 minutes, maybe 60 questions, multiple choice, that kind of thing. But that's just our jumping off point.
It gives us a good framework.
We're pulling out the core principles, the thinking behind it all. That applies whether you're building massive cloud systems or just wondering how your streaming service works so seamlessly.
And that's the crucial part. These concepts, they aren't just theoretical fluff.
Right.
They are genuinely the bedrock. It's how organizations, big, small, doesn't matter, actually manage and protect what's arguably their most vital asset today,
Yeah.
their data.
You said it.
It's all about building digital infrastructure that's robust, resilient, stuff that can handle this insane data growth we see, but also helps businesses actually innovate.
Okay, let's unpack the first one then. It jumps straight into proactive capacity planning for storage. Asks us about the primary benefit.
Okay.
So picture this. Your business data, it's just growing and growing, nonstop, customer info, transactions, media, everything.
The usual story.
And everyone expects things to be instant, fast performance, zero hiccups. So how do you deal with that demand smartly? Looking ahead, where do you usually see the pitfalls?
Well, that's a huge one. So many places end up firefighting,
Reacting.
Exactly. Disks fill up, apps slow down, something breaks. The source answer, making sure the infrastructure can handle future growth and performance,
Yeah.
that's the main goal. But the real insight,
Yeah.
it's not just crisis aversion.
It's more strategic.
It's totally strategic foresight.
Yeah.
You shift from fix it when it breaks to build for tomorrow. Reactive means scrambling, making rushed, maybe bad decisions.
Like overspending on emergency upgrades.
Definitely. Or getting locked into a vendor because you needed something right now. That happens a lot.
That vendor lock-in point is interesting. So it's not just about keeping the lights on, it's actually boosting the business's ability to, maneuver.
Precisely. Proactive planning means IT isn't just putting out fires. They can actually innovate, optimize, align tech with where the business wants to go long term.
Right.
Think about it. If your storage is always a bottleneck, how can you roll out that new AI feature or expand quickly?
You can't. The infrastructure holds you back.
It becomes a liability. Good planning turns it into an accelerator. You build something that can adapt, not just struggle to keep up.
That's a really powerful way to put it. You're future-proofing, essentially, like building that road network for the traffic you expect in 5 years, not just for today's jam.
Exactly.
So it hits efficiency, cost, and crucially enables innovation without things grinding to a halt. Ties right into that knowledge point. Storage capacity planning and performance management. Can't argue with that.
Non-negotiable, really.
Okay, so if planning handles the new data, what about all the old stuff? Our next question gets into archiving solutions and this thing called a file stub. This sounds kind of like magic. What's the deal with this stub?
It is a bit like digital sleight of hand, yeah. The problem is simple. Tons of data gets generated, but honestly, a lot of it goes cold pretty fast.
Yeah.
Inactive.
But you still need to keep it, right? Compliance, legal holds.
All that. But keeping it on your expensive, fast primary storage, that's wasteful. So you
Right.
archive it, move it somewhere cheaper for the long term.
Makes sense.
The genius of the file stub, like the source says, is it's just a metadata pointer left behind on the primary storage. It points to where the actual file went.
Okay, hold on. How does it work in practice? The file is physically gone from the main system.
Right. Space freed up,
But for the user or the app, it looks like it's still there. How?
that's the illusion. The stub is tiny, just a few gigabytes. Think of it like a forwarding address.
Okay.
It holds just enough info to know, hey, the real file is over here in the archive. When someone clicks on it, the system sees the stub, intercepts the request, and pulls the file from the archive seamlessly.
Transparent.
The user often has no idea. They click, it opens, maybe a tiny delay sometimes, but often not even noticeable. It optimizes your expensive storage without making users change how they work.
That is clever. It's like a library moving old journals to the basement archive.
Good analogy.
But they leave a card in the main catalog saying, go downstairs to find this volume. Access is maintained, but the prime shelf space is freed up.
Exactly.
So beyond just saving money on storage, what else does this kind of hierarchical storage management do? Any other strategic wins?
Oh, definitely. What often gets missed is this layer of abstraction it creates.
Abstraction.
Yeah, it makes your whole data setup more flexible over time. Data governance gets simpler because the logical location, the snub, stays put even if you change the physical archive storage underneath. It helps with compliance too, you know where everything is. And critically, it keeps your primary storage lean and fast for the active stuff that impacts application performance directly.
Right. So it's performance, costs, and compliance. Hits all the big ones. That fits perfectly with data archiving and hierarchical storage management, HSM.
Foundational stuff for managing data lifecycle.
Okay, let's shift gears. Virtual machines. They're everywhere, running critical stuff.
The heart of modern IT, really.
So protecting them is huge. This next question looks at hypervisor-based continuous data protection, or CDP. It asks about a key characteristic of how it replicates data. What makes this approach stand out?
This is where data protection gets, well, pretty sophisticated. Forget traditional nightly backups or installing agents on every single virtual machine.
Which can be a management headache.
Totally. Hypervisor-based CDP works deeper down. The key thing, as the source material points out, is that it captures changes by watching the I/O, the input-output operations, right at the hypervisor level itself.
Okay, the hypervisor layer. For listeners maybe not deep in virtualization day to day, can you quickly unpack what that means? Why is operating there such a big deal?
Sure. Think of the hypervisor as the foundational software layer that creates and manages all the virtual machines running on a physical server. It's like the landlord for all those VM tenants.
Got it.
Because it sits between the physical hardware and all the VMs, it sees everything.
Yeah.
Every piece of data written or read by any VM.
A central viewpoint.
Exactly. By capturing changes there, you protect all the VMs on that host without needing separate software inside each one. That means less overhead, simpler management, no agent conflicts.
That sounds way more efficient. And what about the continuous part? Capturing changes almost in real time, what's the benefit there?
The benefit is huge for your RPO, your recovery point objective.
How much data you can afford to lose.
Right. With old school backups, maybe you lose hours of data. With this kind of CDP, because it's watching I/O constantly, your RPO drops to seconds or maybe minutes.
Wow.
You get these incredibly granular recovery points. You can rewind to just before something bad happened, corruption, ransomware, whatever.
So much faster recovery, minimal data loss.
Minimal data loss is key. It helps businesses bounce back from really nasty disruptions much, much faster. It's a serious safety net for virtual environments. Fits right into data protection and virtualization technologies.
Okay, let's talk security now. Always top of mind. We're looking at securing the SAN, the storage area network.
The backbone for block storage.
Right. And the worry is unauthorized access, maybe a server gets compromised. How do you stop that rogue server from grabbing data it shouldn't? The question asks for the most effective way to prevent access to a specific LUN it's not authorized for. What's the main threat vector here?
We're talking about internal compartmentalization, least privilege but enforced in the storage network itself.
Okay.
Maybe a server got popped malware, stolen credentials, could be anything. Could even be an admin mistake. The point is, something has access it shouldn't. The most effective countermeasure. Our source is spot on, configuring LEN masking and zoning within the SAN fabric.
So this isn't just about network firewalls or encrypting the data itself. This is deeper.
Much deeper. It's security built into the storage network's plumbing, enforced by the SAN switches and storage arrays themselves, very granular.
Okay, break down zoning and LUN masking. How do they work?
Think of the SAN like a secure vault. Inside, you have lots of locked rooms. Those are your LUNs, the logical disks presented to servers.
Right.
Zoning is like creating specific, secure hallways. It dictates which servers can even see which storage ports or other servers on the SAN fabric. A server in Zone A might not even know Zone B exists.
So it limits visibility.
Exactly.
Yeah.
Then LU masking is like giving specific keys to specific servers. Even if a server is in the right hallway zone and can see a storage array, LUN masking ensures its key only opens the doors to the specific rooms LUNs it's explicitly allowed to access.
So even if a server gets compromised,
And it's sitting on the SAN.
it can't just browse around and access any LUN it sees.
Correct. Its access is restricted by the zoning and masking rules, which are enforced by the hardware. It can only access the LUNs it's been explicitly granted permission for. It can't open doors it doesn't have the key for.
That's a fantastic analogy. The secure building, specific hallways, specific keys for specific rooms, it really shows the layers.
Precisely.
So even if one server is breached, the blast radius is contained. Lateral movement to other data is blocked at a very fundamental level.
It's a critical defense mechanism. That's why SAN security and access control is such a vital topic.
Okay, last one. Let's tackle backup optimization. Backups. Essential, obviously, but man, they can be resource hogs.
Huge resource hogs. Storage space, network bandwidth, server CPU.
Right, often copying the same data over and over again. So this question is about target-based data deduplication and backups. What's a major advantage? What problem is it solving?
The core problem is inefficiency. You're chewing up expensive storage with redundant data, and you're hammering your production servers and network during the backup window.
Impacting users, maybe?
Often, yes. The big advantage are source highlights for target-based dedupe. It reduces the processing load on the application servers.
Okay, and that's the key phrase, target-based. We hear deduplication a lot, but why does it matter that it happens on the target side?
It comes down to, where does the heavy lifting occur? Deduplication finding and eliminating those duplicate data blocks takes significant processing power. If you do that on the source server, the machine running your database or email, you're stealing CPU cycles from its main job.
Slowing things down.
Exactly. With target-based dedupe, the source server just sends its data. The backup target, usually a dedicated appliance or smart storage system, does the hard work of analyzing the data, finding the duplicates, and only storing the unique blocks.
So the production servers are freed up to just observe.
Precisely. They aren't bogged down running the dedupe calculations. That's offloaded.
Which means less impact on performance and maybe faster backup windows too.
Both. Less impact on production is huge. Plus, you drastically reduce the amount of backup storage needed since you're only keeping unique data. And another win. Less data needs to travel across the network from the source to the target.
Less network traffic.
Significantly less. So the whole process is leaner, faster, less disruptive. It's about smarter data protection, which ties directly into backup optimization and deduplication techniques.
Wow, okay. We've covered a lot of ground there. From proactive capacity planning, enabling innovation,
to the clever trick of file stubs for cost-effective archiving.
the near real-time safety net of hypervisor-based CDP.
The hardcore security of SAN zoning and LUN masking.
And finally, making backups way more efficient with target-based dedupe. Okay, so as we wrap up, here's something to chew on. Think about the insane amount of data being created every second. It's mind-boggling.
And accelerating.
Totally. So looking ahead, say 5-10 years, what new challenges pop up? How will these ideas, planning, archiving, protecting, securing, optimizing, need to evolve?
Okay.
Especially with things like AI generating even more data, quantum computing, maybe breaking current encryption, data becoming even more spread out.
That's the big question, isn't it? How does this foundation adapt for what's next?
Definitely something to think about. We'll leave you with that until our next deep dive.